Welcome to the Basic Mathematics channel. Today we'll explore the history of the Pythagorean Theorem, understand its meaning in a simple way, and solve a quick numerical example. Let's dive in. What do ancient builders, Indian monks, and Greek philosophers have in common? They all played a part in one of the most famous ideas in math history, the Pythagorean Theorem. The ancient discovery? Thousands of years ago, before calculators or chalkboards, people were building homes, temples, and pyramids. To get perfect right angles, they used a clever trick. Make a triangle with sides 3, 4, and 5, and boom, a perfect right angle. That's the magic of the triangle, long before the math was written down. Babylonians and Indians? The Babylonians, around 1800 BCE, wrote these triangle rules on clay tablets. They didn't know the formula yet, but they used it to make their buildings right. This was happening in places like Mesopotamia, Babylon, and Egypt over 4,000 years ago. In India, the Sulba Sutras explain the same thing, using words to describe right-angled relationships. They didn't call it a theorem yet, but they knew it worked. Pythagoras steps in. Then, around 500 BCE, a Greek philosopher named Pythagoras enters the scene. He believed numbers were sacred. He and his students weren't just builders, they were provers. They showed, logically, that in every right triangle, a squared plus b squared equals c squared. No exceptions, no guesses. Just truth. Euclid makes it official. A couple of centuries later, Euclid writes it down in the Elements, one of the most important math books ever. From there, the Pythagorean Theorem travels across empires, languages, and centuries, into every schoolbook in the world. Now let's dive in and understand how the Pythagorean Theorem is derived. Let's take a right-angled triangle, with its two shorter sides labeled A and B, and the longest side, the hypotenuse, labeled C. Now, imagine we take this triangle and build a square on each of its three sides. One square on side A, one square on side AB, and a larger square on side AC. The goal here is to understand how the areas of these squares relate to each other. We know that the area of a square is simply the side length squared, so the area of the square on side A is a squared. The area of the square on side AB is b squared, and the area of the square on side AC is c squared. Now here's the key insight. If you carefully rearrange and fit the pieces from the squares on A and B, you can fill the entire area of the square on C. This reveals the beautiful relationship. The area of the square on the hypotenuse is equal to the combined areas of the squares on the other two sides. In mathematical terms, this is written as a square plus b square equals c square. This is the famous Pythagorean theorem. Let's solve one example. The question is, a right-angled triangle has one side, A equals 3 units, and another side, B equals 4 units. Find the hypotenuse C. The solution to question is as we know that hypotenuse square equals perpendicular side square plus base side square. By substituting in above equation, we'll get answer as 5 units.